Hi dear student, we'll discuss the 8051 timers and counters which can be used as timers to generate a time delay and a counters to count events it happening outside the microcontroller. So as we know that 8051 has the two timers. It has timer 0 and timer 1. These timers are 16-bit wide. Each acts as 8-bit register. So we can use as TH, it is for higher bit, and TL, it is for lower bit. So these can be 8-bit as well as 8-bit. So timer low, it is a lower 8-bit register, and timer high, it is an higher 8-bit register. Totally it is 16-bit register. So let me see the counters. See the counter, as we know that it can be used as a timer to generate a time delay. Remember, it is used to generate time delay. So as we done in the previous classes, how to generate the time delay and calculate it by using your crystal frequency as well as your machine cycles taken by the each instruction, how we can calculate the delay with the sum of seconds. Instead, we can generate the same way to delay by using your counters. Okay, so as usual, counters in the sense, obviously it is counts the values from, let's say it is 16-bit, it is taken as 002 F. It is counts start from 002 FFF because each are 16-bit count register. Each are 16-bit count register, because as we know the special function register, that is what SFR we called about, all are the 16-bit register. So here we should know that counter reached the maximum value, that is FFFF, then it rolls over, to 000. So whenever it is reached to maximum FFFF, then the flag which is identified as overflow flag. This condition, it says that your count has reached to the maximum level. So that will be set to 1. Okay, so counter start from 0002 FFFF. When your count reaches to the maximum level, then it identifies your overflow flag as set to 1. See, the counts rolls over from maximum count to 00. Remember, this condition we called as rolls over condition. It means that reach to maximums to the comes to minimum. Okay, so then the corresponding timer flag, so remember the corresponding timer flag that is TCON timer control flag, that is what we called as a TCON, is set to 1. Okay, as we said, it is overflow. That overflow occur as a set here in the timer, as whenever it is reached to the maximum level and comes to 00, then TCON flag, that is set to 1. Now we will see that in timers, has a 2 special function registers. Has 2 special function register, that is SFR, that is what we called as T mode, timer mode, and we have TCON. So this is we called as timer mode, and this is we called as timer control. Register. So these registers are 8-bit register. These registers are 8-bit register. Okay, let me see that what is a timer mode register and TCON register. So first we'll comes to the T mode register. See, all our SFR registers, it all are direct addressable register. As we know that in the previous classes, all the in RAM area, that is where we started from the after 128 bytes, the all SFR registers stored in your RAM. So those are, it is directly addressable. They have the addresses. So likewise, we have the T mode register, timer mode. This is an 8-bit register. It is direct address is 88H. We can address directly through the 88H. Let me see that it is timer mode, how we can set the timers 0 or timer 1 with the mode configuration. That will be tells by your T mode register. We need to configure our timer with the mode of operation. So that how we can configure the timer mode. This is as we know that it has 8-bit register. So in 8-bit register, we'll see that each bit how it is configured. Okay, so this is your D7, that is what we called as a gate, and we have the counter or timer bar bit, and this is your mode configuration with M1 and M0. Similarly, we have one more gate, and similarly C counter or timer, and this is your as well mode 1 and mode 0. This is your T mode register. Remember, this is for timer 0 and this is for timer 1. Once you want to configure the timer 0, we can use T mode with this bit D0, D1, 2, 3, these 3 bit, and 4, 5, 6 and 7 are for timer 1. So let me see that how this will be configured with all the bits. First we'll go with the gate. If this is 1, it indicates that start the counter. It indicates that start the counter. If this is 0, stopping the counter. Once you make use of timer 0, you want to make this is 1, then we can say that timer 0 has started. Okay, if you want to make this bit as 1, that indicates that timer 1 has started. So take a note here. So what means that start or stop the counter in two methods. Whatever the timer, we can starting or stopping with two methods. One is hardware method. Like use the interrupt or reset. Okay, like if you want to be start the counter or stop the counter, we can use one as an interrupt, as we discussed in the previous class, that is where ISR has written in the ROM area, that is for the timer 0 or timer 1. Then there we written the program to stop or start the timer, so that we can call the interrupt and we can do the start or stop the interrupt, or we can use the reset button. Press the reset button, then it will automatically stop, or respective to the how you use the counter timer 1 or timer 0, that will be start or stopping. The second method is software method. So here we are using programming. So this is what we doing in our syllabus. So we can write the program to start the counter or stop the counter. So here we have the two methods. Next we have the another one is C bar T bar bit. If this is equal to 0, acts as a timer to generate delay. This you should remember. This is very important concept. When this is equal to 0, 0 indicates that T bar is enabled, so that it acts as timer to generate delay. You want to use the timer 0, then you make this bit has to be 0. Then timer 0 generates the delay. Okay. If you make this as to be 1, okay, it acts as a counter. So when C, it will be 1, so this will be 1, then timer 0 acts as a counter. Clear? So now we'll see the mode of your timer and the counter. So in the examination, probably the question will ask like your mode of operation, timer mode of operation. Okay, let me see that we have bit is M1, M0. We'll say that what is the mode. First we'll make this as both are 0 0, that we call it as a mode 0. So mode 0 in the sense it is 13-bit timer mode. When it is 0 1, it is a mode 1. It is a 16-bit timer mode. So this is probably we are using always because it's the highest bit timer. So this is the one we are using. Next we have 1 0, that is a mode 2. This is we are using 8-bit timer mode. Okay, and 1 it is a mode 3. It is we are using split timer mode. Split timer mode. Okay, so in the examination probably they're asking the explain the timers with the mode 0 or the mode 1 or mode 2 or mode 3. See, we'll see that each individual mode how we can work on this. Now this is very important concept what we learning on that. Okay, so first we'll go with each mode, mode 1, mode 2, mode 3 or mode 4. So then we can understand easily. Okay, see, this is the concept what we learn, that just I representing in the slideshow. See, we are going to discussing the timer or the counter. See, in the 8051 microcontroller has the oscillator with the generating of 12 oscillation that generates your total number of oscillation. So as we know that C bar T bar bit, if it is equal to 0, it acts as a timer. Okay, so in that T mode control, this is the bit that should be 0. Okay, that time whatever we have the timer bits, timer low and timer H, that is totally 16 bit, it will be generated, and this is your timer, it is generated. Okay, next we have the timer flag, that should be 1 when your timer H reaches to the maximum level. So later we'll discuss about the TCON, timer control bit. In that we have the TF0 and TF1, timer flag 1 and timer flag 0. Okay, when C bar T complement, that will be equal to 1, it acts as a counter. So that time your direct timer pin, it is connected to your timer, no need of oscillations there, because once the counter has started from the initial value, and then your timer registers we can use the as a counter. So at that time we are using the timer control registers or TR, timer register, TR0 and TR1. So that time we are using the gate. So as we told that gate, it is start the timer or stop the counter. So because once we are using as a counter, that time only the gate pin will be working. So whenever as well we come to know the start the timer or the stop the timer, we are using the interrupt. Okay, so hardwarely we can stop or start the pin. So once the timer register, timer has started with respect to your gate input, when the gate is 0 or 1 with respect to start or stop with your timer register. Okay, and then your interrupt pin we are used to stop the timer. Okay, so that is the whole process of your timer or the counter of internal structure of your 8051. This is how the operation is happening with respect to your timer mode register. Then we can see that we have the timer mode register gate as what we learned about, that is the address with the 89H direct address gate. If the when a set timer or the counter is enabled, if the pin is high or 0. Okay, Next, when it is cleared, your whatever your stop the counter, that is timer register bit as set as high. Then similarly comes to the C counter or timer bit. When this is 1, then your counter operation has started, and if this is clear, if that is clear in the sense it should be started with the timer. Okay, next we have the mode operations. Then timer mode, remember these are not bit addressable register, so with that 00, as we told that it is an 8-bit timer register, both are 00. It is 8-bit timer TLX server as 5-bit prescaler, that is totally it is 8 plus 5 13-bit timer mode. And 01, it is a mode 1 operation. It's used as your 16-bit timer or the counter. Both are cascaded, no prescaler. Remember, in the first mode 0, it is an 8-bit timer, that is where we are using the timer low register, and other 5 bits, that is a higher bit, that is TH, that will be prescaled. Okay, already it is set the 5 bits. Totally it is 13-bit. Will comes to the explanation there, we are going to be understanding that. Next we have the 10, that is mode 2 operation. Mode 2, as we know that it is totally is in 8-bit. So here we are using fully as timer low register TL0. It is controlled by timer 0 control bit. Okay. TH0 is an 8-bit timer controlled by timer 1 control bit. Remember, here we are using the timer 0 as an 8-bit counter that will be controlled by your timer 1 control bit, that is a 8-bit timer. Both are 1-1, that is a mode 3. As we told, it is a split timer mode. Okay, probably it is used one timer 1, here we oft. Only timer 0 we are using to split timer mode. Okay, so this is what we discussed in the concept of timer mode. Next we learned about in the TCON register, timer control register. Thank you very much.